Hello, welcome to our channel Elimika Mtandaoni. Today let us discuss about very simple concepts, but they are very important concepts that are available in almost all programming languages. These concepts are data types, variables, and keywords. Let's start with the data type. As its name indicates, data type represents a type of data which you can process using a computer program. In fact, speaking of a data type is an attribute of data which tells the compiler or the interpreter how the programmer intends to use data, what type of data the programmer intends to use. Most programming languages support basic data types of whole numbers, we call them integers, and they are of varying sizes. We have floating point numbers, which approximate real numbers. We have characters, and we have some data types that are called booleans. A data type constrains the values that an expression such as variable or a function might take. We'll talk about variables and we'll talk about functions in later videos. So, in fact, speaking of a data type, it's just a type of data or that provides set of values from which an expression may take that value. This data type defines the operations that can be done on a data. For example, if you want to perform an addition, then you need to know what type of data are you dealing with, because it is not possible to add, let's say, a number and a sequence of characters. Let's say you want to add a 3 and a name of a person. That is not possible. So these data types, they define what operations that can be done on the data and the meaning of the data. What does that particular data mean? Is it a whole number? Is it a floating point number? That means it's a decimal, or it is a sequence of characters, or etc. And also, data type provides a way that values of that type can be stored. By knowing that this is the type of data that you want to use in your program, then it makes it possible for the computer to create storage or a memory to store that kind of data. So a data type provides a set of values from which such expressions such as variables, functions, and other identifiers may take. Let's talk about the concept of data type. We say that data types have many uses and they are used within type systems, which offer various ways of defining, implementing, and using such data. We have different types of systems that ensure a varying degrees of type safety. Almost all programming languages explicitly include the notion of data type through different languages, despite the fact that they may use different terminologies. The common data types that used with almost all programming languages include integers, floating points, characters, strings, and even boolean. So now let's keep computer programming aside and let's try to understand what this data type mean. What data type mean? Take an example of adding two numbers. For example, you add number 2 and 7. We know the addition of 2 and 7. 2 and 7 are whole numbers. Think of another example where you add two decimal numbers. Let's say 2.5 plus 10.5. So the two examples, the first one that uses whole numbers and the second one that uses decimal numbers are very straight. But if we consider, for example, we have an example where we want to record student information in a notebook. Suppose you want to record student information in a notebook. You have you want to take the name of that student. You want to take the name of that student. You want to take his class, section where he studies, the age of that student, and the sex of that student. So there we have this first part where we can fill the name. Let's say the name of the student is Agu. Then this student studies in class 6th. Then the section is studies in section C, and the age is 13, and the sex of this student is male. So we have put the record as per the requirements. Now, the first example just dealt with the whole numbers, as we have seen that we have 2 and 7 as whole numbers, and the second example added 2 decimal numbers, whereas the third example now is dealing with a mixture of different data. We have student name. For example, we have said that student is called Agu. So a student name is a sequence of characters which is called a string. A string means you have characters. Let's say you have A, B, U, G, and U. This is a character, this is a character, this is a character, and this is a character. So the combination of all these characters make up what we call a string. So it is a mixture of characters, of 2 or more characters, and we call it a string. So the proper name for a collection of characters, we say that is called the alphanumeric. Alphanumeric. That means we can have characters that make up a word, or we can have a mixture of words, a mixture of letters. Let's say AG 1, 2, 3. So a mixture of letters and numbers together, they create what we call alphanumeric characters. Alphanumeric characters. Student section has been represented by a single character, as we have seen that student section, we say this student is in section C, and we can put that. So this is just a single character. So this is another type of data that we call it a character. Simply, it represents a single letter or a single number. So that is called a character. When we come to age has been represented by a whole number. Age has been represented by a whole number. That in programming, a whole number we call it integer. A whole number we call it an integer. Now, student sex also has been represented by a single character, which is M. That means M is also a character. So from this example that we call example 3, we have a name which is alphanumeric. Then this is a string, a type of data that we call a string. We say again class. We say this is sixth. That means there is a number and there are letters. So this kind of mixture of this type of data type, we call it alphanumeric data type. In the section, we have used another type of data that is called the character. Another type of data that is called the character. In the age, we use the whole number, that is an integer. And again, data of sex was represented by a character. This way, now we can realize that in our daily life, we deal with different types of data. We deal with data that are called strings. We deal with data that are called characters. We deal with the whole numbers that we call them integers. We deal with the decimal numbers, or that we call them floating point numbers. So if we list down here, then we can say that we have integers. These are the whole numbers. We have strings. This is a sequence of characters. We have floating point numbers that are decimal numbers, floating point numbers, and we have also some double floating point numbers we'll discuss later. We call them double floating, we call them double. So we have seen an example of data types and how we use them in our daily lives. Similarly, when we write a computer program to process different data types, we also need to specify the type of data that can be used. We specify that clearly. Otherwise, the computer won't understand how different operations can be performed on that given data. So the concept of data type is very important. The concept of data type is very important. We have different programming languages. And thus they use different data types. For example, programming languages such as C or C++. Programming languages such as C, there is a programming language called C. We have another one that is called C++. We have another one that is called C#. We have another one that is called Java. All these programming languages, for example, all these programming languages, they use int. They use the word int to represent all types of data that are whole numbers. Int stands for integer. So once you are writing a program using C++ or using a C programming language or a C# programming languages or a Java programming language, then if you want to specify that the type of data you want to use is a whole number, then you specify it using a keyword int. If you want to specify, let's say, a character, as we have said, character, like let's say C, you want to represent C, or you want to represent J, this is the type of data that you want to use in your program probably. Then if you are writing that using C++ or C or C# or Java, then you can represent it by writing a char. You say CHAR. In the subsequent videos, we will show you how to use different data types in different situations, but in just the coming slide here, we will talk about variables. That is one situation where we can use data types. Now we have moved to data types. We have moved to variables, but before speaking about variables, let's talk a little bit about these data types. As we have said that we have C, C++, C# and Java data types. These languages support almost the same set of data types as we have seen in the previous slide. They have the same set of data types. Though with the Java supports some additional data types. We will see in the coming videos where we will be talking about Java programming languages. So, but those data types that are shared by these other programming languages that include C, C++, Java, and C#. We have a data type called the character, as we have talked about character. Character takes values that range from -128 to 127. All the values range from -128 to 127 can be stored with this value called the character data type. Or you can say you can range a value from 0 to 255. Values from 0 to 255. It can take all those values as data type. Then we have another data type called a number. We call it int. In short, we call it int in these programming languages C, C++, C# and Java. This takes a range of values from negative 22,768 to 32,768, or you can take a range of negative about 2 billions, etc., to negative 2 billions to 2 billions, positive numbers. And in fact, speaking of whole numbers can exist in different forms. We have some whole numbers that are small numbers, then these are called small, like this one, called small. We can have long numbers that they range from 2 billions, as we have said. We have long, and we have integer. So it means that integer, short and long, they are all called whole numbers, but it depends whether that number is long or is short. If it is a short number, then we call it short. If it is a long number, we call it long. Then we have some decimal numbers that we call them float. We say they are called float. These data types, all these data types that we have specified, character, number, small number, long number, decimal number, all these data types are called the primitive data types, and you can use these data types that are called the primitive data types to build more complex data types. So in the later videos, we will talk or we'll discuss how we can use these primitive data types to create more complex data types, which we call them user-defined data types. For example, a string. In fact, a string is a sequence of characters. That means if you have a string, it means you have a collection of characters. So a string is one among the user-defined data types, and it is somehow complex because it is made up of other primitive data types. So we have looked at these programming languages: C, C++, C#, and Java. We have some other programming languages. Let's say Python. Python has 5 standard data types, but this kind of programming language does not make use of any keyword to specify a particular data type. But these other languages that we have talked, the C, C++, and Java, these use some keywords. They use some keywords to specify a type of a certain data. But with other programming languages such as Python does not use any keyword to represent data type. Now it's time we move to variables. Now let us discuss about variables. Speaking of variables, variables are names that you give to a computer memory locations which are used to store values in a computer. So think of this as a computer memory. Let's say this is your random access memory. Think of it as a computer memory. Then you saying that you are creating a variable. You are creating a variable. That means you take this computer memory, you divide it into a certain portion, then you give it a name. You give it a name and you wait for it to be stored with a value. For example, let's think of a variable that we want to create in a computer memory, and we call that variable X. So it means if this is your computer memory, then you divide your computer memory. Let's have a nice drawing. For example, this is your computer memory. Then you divide a portion there in your computer memory, and you give that portion a name called the X. That means you are preparing this place here to store certain values. That those values will be the ones that will be used in your program. For example, assume that you want to store 2 values. Assume you want to store 2 values. Let's say you have a value of 10 and 20 in your program, and at a later stage you want to use these 2 values for certain purposes. So now let's see how you will do that. For example, think of this is your computer memory. Then you want to store two values. If you want to store two values, let's say the first value I will call it x, and the second value I will call it y. So it means after I have created spaces, I have created memory locations in my memory, then now I can put my value, let's say 10 in here, and I can put my other value, let's say 20 in there. So there is what we say, we have created memory locations to store values in a variable. So what steps should we follow as we want to do that? As we have said, we want to store two values, say 10 and 20. So steps that you should follow: the first one, you have to create variables with appropriate names. That means if you have, let's say, three values, there we have said we have two values. If you have two values, then you have to create two variables. Say, as we have said, for example, we create the first variable called x and the second variable called y. So we have created two variables. Then after creating such variables, we store those values in such variables. They say in x we put the 10, and in y we put the 20. Then what is the next step? The next step, we can retrieve the values from the stored from the stores. That means we can retrieve the value from x and retrieve the value from y and use them. So now let's move to creating variables. Speaking of variable creation, we say creating variables is also known as declaring variables. So if you hear somebody in C programming, or in C++ programming, in C or in C++, or in C#, or in Java, or any other programming languages speaking about declaring variables, that means is creation of a variable. Different programming languages have different ways of creating variables inside a program. So now to show you this, I will open a compiler. I will open a compiler and show you how we can create variables. How we can create variables. As you can see now, we are in here. We want to create two variables to store two values, to store the 10 and to store the 20 value. So as we know that 10 and 20, they are all whole numbers. If you refer back to what we have been talking about data types, then we will have to store a place, we will have to create a place where we can store values which are whole numbers. So such values must be of type integers. So if I want to create now, I will say I will use the keyword int. The keyword int represents that the variable that we want to create is of type integer. That means it will take values which are whole numbers. So I will say int x, then I will put semicolon. If you go back to what we talked about syntax, syntax for C++ says that after the ending every sentence in C++, we put a semicolon. Again, we say int y, then we put semicolon. So what we have done here by saying int x and int y, this is what we call a variable declaration. I'm writing there variable declaration. That means we have created a variable called x and we have created a variable called y. So that is called the variable declaration. So that program that you see has created two variables to reserve two memory locations with names x and what and y. We have created these variables using a keyword called int to specify that variable data type means that we want to store an integer value in these two variables. So similarly, you can create variables to store long, to store float, to store character, or any other programming language or any other data type. For example, if you wanted to create a variable that will take decimal numbers, then we would say float, let's say f, then we put semicolon. So if we wanted let's say to declare a variable of type short, then we could say short, then you put whatever name you want to give. For example, short, let's say name, short name. Or if we wanted to create a variable or that will take long integers, then we could write long name, something like that. You see, so this is how we create variables. Creating variables, you start with the type of data, the keyword for the type of data, then followed by a name, you can create variables of similar data types. As we have said, you can use different data types. But there are some key points that we need to know about variables. You need to understand and you have to keep in mind the following. A variable name can hold a single type of value. For example, if you have that variable called hex, it has been defined of type integer, then it can store only integers. So you cannot say int x and you want to put, let's say you say you have said int x and you want to say x to take value, let's say take a name, say you want to put Agustino in x. This is syntactic error. We have talked about a basic syntax, you remember. That means if you have a variable name of a certain type, then that variable name will carry only such data types and no other data types. If you are doing programming in C++, then it requires to do a variable creation or declaration of variable before you use it. There are some programming languages that allow you to just use a variable name without first declaring it, but some strongly typed programming languages like C or C++ or C# or Java, or even some other programming languages like Visual Basic, etc. All these programming languages, they want you first to declare a variable before you use that. So you cannot use a variable name in your program without creating it. If you do that, then you will create an error. For example, as for now here, we see our program. If we try to run this program here, as you can see, it is compiling. If you want to run this program, as you see, it won't bring anything, no error, no what. But if you want to try, if you try to use if you try to use let's say a variable name that has not been declared. For example, I put here a variable name, let's say name. I put it the word name here, and I want to run this program. If I run, it will give me an error, simply because you cannot use, you see, you get an error. That means you cannot use a variable without declaring it. But if I decide to declare this variable, let's say type character, then I say car, then I put name car, put a semicolon. If I run this, then there is no any error that I will get. So you have to create, as you can see there, you see, if you don't want to get some syntactic errors, then you have to declare a variable before you use it. Another important point with variables, you can use a variable name only once inside your program. You can use it only once. For example, if a variable x has been defined to store an integer value, then you cannot define it again to store any other type of variable. For example, here I have declared x as my variable. Then again I want to say car x. That means I want to use the same name but different data types in a program. This is not allowed. This is not allowed, simply because you can use a variable name just once. As you can see, we have got an error. That means it is not allowed for us to use different names but different data types. There are some programming languages like Python, PHP, or Perry, such programming languages which do not want to specify the data type at the time of creating a variable. There is no need to specify the type of data the time while you are declaring a variable. But for some other languages like C++, C#, C, and Java, they require you to first specify the data type and you use it. But these other programming languages like Python, PHP, Perry, etc. do not require you to specify that data type at the beginning of creating a variable. So you can store integer, you can store float, you can store long without even specifying the data types. You can give any name to a variable. Let's say you can say variable is called age, a variable is called sex, a variable is called salary, or a variable is called anything that you want to. For example, I can say there is this variable that I say int salary. That means I have created a memory space for me to in a program to store a certain values, whole numbers that represent salaries. I can name a variable as a name. I say int name. I can name it as number. I can say the word, you can use the word number, things like that. So most of the programming languages, they allow you to use only limited characters in the variable names. You cannot have a variable name with a lot of characters, a very long. Some limit you to 8 characters, some limit you to more than 8 characters. It depends of which programming language you are dealing with. Almost none of these programming languages allow you to start a variable name with a digit. You cannot say that you are creating a variable name called 23 name. Kwa mfano 23 name. This is not allowed. For example, here, if I try to run this program, it will give me some errors simply because a variable name cannot start with a number. You see, a variable name cannot start with a number. Or you cannot create a variable name with a character. Let's say I want to name a variable name as name. Let's try this and see what happens. I have used a character, an ampersand symbol, and a name. You see, it gives me an error. So, or you want to start with some arithmetical values. Let's say you start with the plus. Then you get a gas. Say this is my variable name. I'm creating a variable name like this. It will also give you an error. So there are a number of rules that you have to adhere while you are creating variables for your program. But let's move on. Every programming language provides more rules related to variables, and in fact you will learn them when you will go in further details of each programming language. So if you start each and every programming language, then you can follow some rules of naming variables in that particular programming language. Now, after we have understood that how we can create a variable or how we can declare variables, then now that we have seen how we can do all that, let's store some values in those variables. Let us store some values in those variables. So storing variables storing values in variables, we call it assigning values. As we can see, the program that we have seen, we have int x, int y, int salary. That program has some additional statements where you can store values. You can store values, let's say the value of 10, the value of 20, the value of what, because they have created variables that can store whole numbers. So almost all programming languages have a similar way of storing values in the variables, where we keep the variable name in the left. So we put the variable name in the left, and we put an equal sign, and whatever value that we want to store in the variable, we keep it in the right hand side. So if we want to store value in the variable x, then we say x followed by an equal sign, then the number that we want. Because this is an integer, that means it must store a whole number. So I will put here 45, then I put semicolon. Again, if I want to put value in y, then I say y is equal to 67, then I put a colon. Then in salary, if you want to put a value in salaries, then we write salary, we put equal to, let's say this salary is 1,000. That salary is 1,000. So we put semicolon. Now by this doing, that means that after we have created a variable, then we put values, we store values in such variables. Then let us try to run this program. If we run that program, it is an okay program. Now this program is okay. Now we have completed 2 steps. The first step, we created 3 variables, and then we stored some required values in those variables. Now that variables, these variables have values. We have put 45 in x, and we have put 67 in y. In other words, we can say that when this program is executed, memory location named x will hold 45, and memory location known as y will hold 67, and memory location with the name salary will hold 1,000. Now after we have a stored value in variables, now let's learn how we can access these variables. Let's put this aside. How we can access these variables. If we do not use the stored values in the variables, then there is no point in creating variables and storing values in them. So let us stop here. We will proceed. Let us proceed now. Let us proceed. Now that we have created our variables and we have stored values in such variables. Now let us learn, if, as I have said previously, that we create variables so that we can use the values that are stored in the variables. If you don't intend to use values that you can store into the variables, then there is no need for you to say you are creating a variable. So we know that the above that program has 3 variables. We have variable x, variable y, and the variable salary, and they store the values 45, 67, and 1,000 respectively. So let us try to print those values that are stored in those variables. Now let us try to print them. So in C++, how do we print values? In that, we use the keyword cout. Use the keyword cout, then cout followed by that symbol. Then we want to say values in x. For example, we want to say values in x, values in x. Values in x is equal to, then we put that. If you want to show that value in x, then we put the word that symbol x. The values in x is that. If we try to run this program now, it will give us these words, values in x. It will say values in x is equal to 45. It will say values in x is equal to 45. Now let us try to run that program. We are executing, but before executing, we compile. So you see it says values in x is equal to 45. That means the value that has been stored in x now is displayed there. The value that is stored in x is displayed there. The value that is displayed there. Then if you want again to show the value that is in y, the value that is in y, we'll say again cout. We say cout. We say cout. Put cout. Say values in say values in y is equal to values in y is equal to, then we put there y, again put semicolon because that is the end of the sentence. So we run that program. After running that program, we'll see now two sentences. One will say values in x, you see there values in x is 45, and again another one will say values in y is equal to 67. So if we want again here to show another value in salary, we can write again, we can write that symbol, and then put the word let's say let me put a comma before here, put a comma, and we finish it by putting the word salary, with the word salary. So here the program will output the following. We'll say values in x is 45, then the program will again say values in y is 67, and then it will write salary equals to then it will put a comma and put the 1,000 as a salary. So let's try to run this program. Let us try to run that program and see what happens. So the program now is running. The program is running, and you can see it says values in x is 45, values in y is 67, then comma, and 1,000 is put there. So this is how we create a variable, and as we have said, creating a variable is called the variable declaration. It's called the variable declaration. And after you have created the variables, then you can store values in such variables. After that, again, you can use such values. You can access values from the variable to print them in the screen, or you can use them in other applications like arithmetic applications or whatever. But let me tell you one thing. There is something that we call initialization, variable initialization. Speaking of variable initialization, it means that when we're talking about initialization, that means while you are declaring a variable, you can also store a value in that variable. For example, when I say int x, and I say int x is equal to 45, and again I say int y is equal to 67, that means I have created a variable and also assigned a value to that variable at the same time during declaration. So this will be called variable initialization. We call it initialization, variable initialization. Doing that and doing as we did the previously, it's the same. You can declare a variable and then use the variable to store value, or you can store value at the same time you are declaring a variable. So here, if I say cout, and I put x, put my x there, then again I put my y, put y there, put y, then I put my semicolon. This means if this variable will print 45 and 67 in one line without a space or whatever. So if I run this program here, it will give me 45, 67, although it may write it as a single number, whole number, like as you can see, like 4,567. If you don't want it to write in that way, then there you can separate them with a comma. So you can put this, then you put a comma, and again you put this, but you also finish up with the those symbols. So if we run this again, it will give us 45, again comma 67. So let's try to run that. If you run that, program, then it will give you the value, as you can see, 45,67. So I guess at least you have understood the concept of variable. You have understood the concept of variable and why should we declare variables. And now let's proceed with our discussion on variables. And this is the third lecture. As you know, that is a third lecture. It's quite a long lecture in programming principles, as we have talked about. We are in the series of videos on programming principles. It's quite a very long lecture that I have given to students. Now, as we have seen how we can access stored values in a variable, now let's discuss about keywords. So far we have covered two important concepts that are called variables and their data types. We discussed how we can use data types like int, long, and float to specify different data types. We also learned how to name the variables and to store different values in such variables. There are many keywords that are supported by programming languages. Different programming languages provide a different set of reserved words. For example, we used the words like int, float, the words like car. So there are different sets of reserved keywords, but there is one important and one common rule in programming languages, that we cannot use a reserved keyword to name our variables. So if you want to create a variable, you cannot create a variable using a reserved word or a keyword. For example, you cannot create a variable with a verb with a keyword int or with a keyword float. You say, I need to create a variable called int. No, that is not allowed, which means that we cannot name our variables like all other reserved keywords, int, float. We have a lot of keywords. For example, in C++, we have keywords like auto, keywords like break, case, car, const, continue, default, do, double, else, enumeration, extem, float, for, goto, void, size of, static, while, switch, register, return, signed, and a lot more, union. So you cannot name a variable name using a keyword, or you cannot name a variable name using reserved words. So thank you very much with this very long lecture on data types, variables, and keywords. It is my hope that you are getting to understand programming. You are getting to understand programming, and I promise you, you are going to be a very good programmer, a person who can write a programming, a person that can write a lot of programs. So don't stop following Elimika Mtandaoni. Please share this video to all other people. Tell them to subscribe. Tell them to listen to the videos and understand what we're explaining about principles of programming. And by understanding these principles, then in the later videos we will come to discuss about several programming languages, one after the other. Then in there you will be able to create lots of programs, lots of softwares that you can use to change the world. Thank you. This is Elimika Mtandaoni, and I'm your instructor, Agustino Mogos. Thank you.